Yeah, okay. We were talking about wine world and the rest of the analysis. I was talking about region, also regression, and I have to continue in the last regression as well. But today I decided to uh, talking about the extension of wine world for now, right? Here I hope to show you how to load a diff document using R. So let me share my screen. Right. Okay. So let's see. According to the time given, I'll try my best to show you this. If you have much more time, here we can try NDVI, right? Right. Okay. So, in order to load these TIFF documents, TIFF files, it means it reads raster images, right? So then it is made of pixels, right? So we need to load libraries, these libraries in advance, stars library, and library SF as well, right? Okay, I'm gonna load them in advance. Then we will go through some examples. First of all, I think it's better to talk about some examples, and you can get a better idea about this, right? So I have this document name is nip. Then we will see. We will have plans on that. Uh, okay, I'll call it as KSP, right? Then read underscore stars. With our experiences, we have loaded different types of data types, data extensions. We have worked with CSV files. We are pretty familiar with CSV files now, right? And Excel documents we have read, right? And text documents as well. And not only them, but also transactions, right? They were even turned into the readable document, right? Okay, then snap dot if actually I have set the direction in advance on my current working space, you can see this is our rich regression, right? I have used the same space, right? Okay, somehow let's see. I wanna check this KSP. It should be working properly. Now you can see the summary of the dataset, how it is made of, right? How many bands are there, minimum values, and everything. From 1 to 4, there must be this much of bands. Okay, let's see. I want to plot it, right? I want to plot it. Let's say simply plot. I'm not going to use ggplot2 here because it's taking too much time on my PC. Therefore, I'll prevent from using that. Right. Okay. Then plot KSP. You can see the result. Right? Still is being processed. So, so you can imagine what a wonderful speed it's having, right? Okay, somehow for the video I have to wait for it. Hopefully, right. Actually, I wanted to talk about even NDVI which is normalized difference vegetation index. You can see here, right? It's kind of popular index which can be used to measure the healthiness of cultivation, not only cultivation, but also we can find out some clusters, or even we can classify images. Those are taken from satellites and even aerial photographs, right? This is widely used in remote sensing and GIS, right? Okay. Somehow I am not related to any of those streams, right? Somehow I have loaded my diff file for you, right? Now you can see there are this much of bands, but the last band is the blank one. It is like this, it is within this frequency, right? So I want to split all of them into a single one, right? Let me call it KL, right? Let me call it KL. Let me make this comment, right? I will use split, right? Split function. Side split function. I'm gonna include KSP, which was made in advance, right? Which was loaded in advance, then band, right? Band. Okay. Then let me plot KL, right? Let's see how it will be look like. Right, okay, you can see now we can split them into different bands, right? You can load each band's distinct, right? Let me load the first band, then let me call it main. Main equals, let's say, okay, right. Okay, if I want to load the third band, right? Let's say wine world with support band 3, right? Okay, it's nothing else, just for fun. So let's see how it will be look like. You can see the third band, right? Band 3. It's within this frequency, right? Okay, likewise you can play with it, right? So actually, I'm not going to analyze my document, right? Here, I'll show you how to compute NDVI. So first of all, I have to load this document. Okay, let me call it D, right? System dot file, right? File system dot file. Then I have copied the directory over here. This is the directory of the system. I cannot keep that in my mind, therefore I have kept it over there, right? This is the directory of the system. Then we need package. We need this package. Package equals stars. Stars is needed. Actually, it was loaded in advance, right? So inside this package, we have this data set, right? So I want to read it. I will call it. This is a popular data set, right? This is a popular file of Brazil, right? So I will call it Brazil, right? I call it Brazil. Then this must be read as a stars as a TIFF document, right? So that's why I'm going to use the stars function it should be readable, right? Then T, actually it's a TIFF document, so no need to put the extension again. So you can ask to plot Brazil, right? Plot Brazil, right? Okay. Now let's see. As earlier, you have to wait. Um, yeah, okay. This is not needed because this file, right? No needed to put it the invited commands, right? Okay, now it should be working. Right, okay. You can see this part of Brazil and I don't know whatever the satellite this was captured, then maybe there are 6 bands, right? Okay, there's a frequency range, so it's made of pixels, right? So even you can see the summary, and you can find out how many, how many pixels and what is the range, and all the histograms, all these distributions of these pixels can be found out, right? Somehow, with the historical data of this data set, I found that near near infrared near infrared band is given by fourth band, right? And third band stands for the infrared, right? So right, okay. First of all, I'd like to explain you a couple of things about NDVI, right? So what is this NDVI? Actually, give me a few moments. I will put my tablet. Yeah, okay. What is this NDVI? Actually, this is one of prolific index which is used to measure the healthiness of cultivation. Or even we can use this. Actually, let me check that it is being recorded or not, right? Because actually, I want to make sure with it. Otherwise, I have to do it again, right? Mm, what happened? What happened? What happened? No, no. What's going on behind it? Right, okay. It's been recorded, right? Somehow, I was talking about NDVI, normalized difference vegetation index. These are one of prolific, one of famous popular index. There are some more indices to measure the healthiness or the healthiness. Actually, here we can compare the healthiness of the cultivation, right? You know that these uh, plants, trees, vegetation, they are the visible color is green. So because there are some cells named chlorophylls. Actually, I'm not aware of them too much about those biological factors. As I remember, I think there must be some cells named chlorophylls. Then chlorophylls absorbs, right, and it emits or reflects green ranges, right? That's how this is seem like that, right? So somehow the healthiness of plantation, of cultivation can be indicated with the help of these frequencies, right? Those are captured with the help of satellite images and aerial photographs as well, right? Okay, so then NDVI is given by, let me use okay, right, okay. NDVI. NDVI normalized difference vegetation index, right? Normalized difference vegetation index. So NDVI is there is a relationship between near infrared and infrared visible, right? Infrared visible. So actually this is given by the difference between the ratio between the difference of near infrared and IR, right? Infrared visible. This over infrared, near infrared plus infrared visible. So it is given by the ratio between these two, right? Okay. Higher NDVI, right? Actually, this is existed in between -1 and +1, right? Let me actually, I'm not going to talk about this widely, right? Just I will give you some idea briefly about this index, right? So high NDVI value stands for a healthy cultivation, healthy plantation, right? So it means that the agricultural, even we can classify geospatial data based on this NDVI, right? And if there is a higher NDVI value, it means that there could be plenty of plantation, right? So likewise, even we can capture um, canopy areas, even we can capture some forestry areas can be captured, right? Okay, they can be identified. Then very low, if NDVI values are pretty close to -1, they can be caused with minus values, especially water bodies can be indicated with the help of minus NDVI values, right? Likewise, if it is around 0, if it is pretty close to 0, it means that it could be a soil, land area, right? So likewise, using these images, we can analyze it, right? Okay, in order to make, actually, we are looking for a healthy forestry area, right? So in order to make a healthy forestry area, we should find out higher NDVI values, right? Then near infrared must be larger. It must be larger, right? Say large NIR with less infrared, right? Less infrared visible, right? Low. Then the difference will be higher, right? The difference will be higher. And the denominator. What about the denominator? This is larger, this is large, right? So we can expect the numerator is going larger, right? Then the NDVI value is going is being increased, right? It tends to 1, right? Likewise, if these two values are going to be equal with each other, it means that it's going to be 0. It's like it represents a land area, right? If NIR is less than IR, it means that the NDVI is less than NDVI is less than 0. It means that it's pretty close to water bodies, right? Likewise, okay. We will do it within few seconds later after explaining this, right? Okay, now I think you could get the idea of this equation, how NDVI is given, right? And the relationship and this value range, what does it say, right? Likewise. And then if NIR is, if near infrared is less and infrared is larger, there is a minus value for NDVI, right? It's for water bodies. It's for water bodies, right? There is a higher capability of finding out water bodies around these regions, right? Right. Okay. Because of these emissions and absorptions, right? Okay. So that's all what I wanted to talk about in NDVI. Should briefly I have introduced you, then you can get an idea about the region using NDVI, right? Briefly, I explained. Actually, I didn't explain the chemistry inside that, right? I have explained you these values and three levels of them, right? Okay, let's go through that. Keep it right. Now, we're gonna go ahead, right? Okay. I want to put them into a single, right, split. Let's say, let's say band, right, band, and then split. What's going to be split? Brazil is going to be split. Brazil with band, right? With band. Okay, then can see plot. Let it be plot band. Plot band. Okay. Okay, this is one. This is one, right? So likewise, we can individually plot each of your bands likewise, right? In my early case, all of them will visualize at once, but here we can visualize them distinctly as we wish, right? Okay, so in order to find out the NDVI value, I said that the fourth band stands for the near infrared, and third band stands for the infrared visible, right? So according to equation, NDVI is given by the difference. There is a ratio, right? Ratio. Whatever is in numerator, numerator is made of what? The difference between NRA and IR, right? Sorry, infrared, visible. Yeah, okay. All are same, right? Okay, come on, let's go. Band. I want a fourth band, and all the others difference, right? Band, and third band, right? And the ratio between the summation, subtraction, and the summation between them, right? Okay, let's go. Okay, now the summation, right? Okay, NDVI. You can see, actually I want to plot it, right? Now I am looking for the map raster image, right? NDVI is going to be plotted, but I want to use color ramp is set it, right? Color RAM palette, right? Palette is added, right? From the low value, let's take a look at this. Low must be started with low means minus values. Must be started with red, right? Red, then the middle one, 0. Very close 0, it represents land area, right? Then it will be represented with the yellow color, right? And then healthy cultivated forestry regions will be designated with green color, right? And as I'm green, then actually this must be put inside an array. It must be made as an array, right? Okay, then I missed another parentheses. I missed another parentheses inside this. I want to use the gradient, right? Okay. Shall I put the title, right? Title. What's the title? NDVI. NDVI of what? NDVI of yeah. Actually, this is a Brazil image, right? Brazil image. I don't know whatever the position exactly, right? Even we can check it with the coordinate system, right? Right. Okay. Everything is fine. Then we can visualize it. Okay. Let's see. Now, higher NDVI value represents healthy forestry regions, right, respectively, and green represents land areas, and red represents water bodies, right? If you have changed this color and palette, it will be changed. I have colored it, I have coded it from logo, right? Okay, this is one. You can see this NDVI value range, right? From -1 to +1, how it is propagating, right? So this is the what I wanted to show you. In green color area can be said that it's a very healthy, respectively, it's a very healthy planted, cultivated area of forestry. It could be even forestry area. This red color, in red color, you can see water bodies, right? Actually, it's the ocean, I think, right? Right. Okay. I will stop it by here, right? This was done for a special request. Hope you could understand it. So see you later, right? Okay. Thank you for all.